Hi guys. So today we are going to learn both the easiest and hardest methods for solving a system using matrices. Now the easiest method is going to be a calculating method associated with what we're about to do. The harder method is going to be the paper and pencil method that we're going to go through with these matrix operations. So the first thing we need to do is we need to find what's called an augmented matrix for a system of equations. So what that is, that's kind of your matrix that really represents that system. So for a 3-variable system, what we're going to have is a 3x4 matrix, 3 rows and 4 columns. The way we're going to set it up is we're going to use the coefficient of all of our x's in the first column, the coefficient for all of our y's in the second column, the coefficient for all of our z's in the third column. Then the fourth column is just going to be all of your answers on the other side. Sometimes you'll see like a dotted line here. Sometimes you'll see a colon here. Sometimes you'll see a line separating it. You don't have to have that. It's just kind of up to you. Whatever makes it easier for you guys to see that system and understand what it represents. But the important thing to know is that this first column is the x's, then the y's, then the z's. All right, in order to write that augmented matrix, we need to make sure that our system is in standard form. So if it's not, we need to rewrite it so that it is. So this first equation is good. We'll go ahead and put that 0 in just to make sure we don't miss it. Then this one I would need to add that to z over. And then on this last one I would move all of this over. Once that's in standard form, then again we just write our x coefficients in the first column, y coefficients, z coefficients, and then the number. All right, so once we know how to do this, we're going to go ahead and start with the algebraic way and using something called Gaussian elimination. So what we're going to do is we're going to get the matrix into something called row echelon form. And the box is cut off on this slide, but let me go ahead and show you guys. It's on the bottom of your notes there. Gaussian elimination, when it's in row echelon form, is going to look like this. You've got a diagonal of 1s, then you've got a triangle of 0s, and then you've got just any random numbers basically right there. That basically, what that's going to do is going to create a system that's incredibly easy to solve. Because what we'll know is that we have 1z equal to this number, and then 1y plus z, whatever z is, and then you already know what z is. So what this does is it creates a very easy to solve system. So our goal is to get a triangle of 0s in the bottom left corner and a diagonal of 1s. And the way we get that, there are basically 3 operations that we're allowed to use. We can swap 2 rows. We can multiply a row by a constant, which also means divide because we can multiply by a fraction. Or we're going to add a multiple of a row to another row. And that's probably the one we'll use the most often. So what we're going to do to start here is we are going to write the augmented matrix. All right, so then again, remember our goal. Okay, our goal is to end up with a diagonal of 1s. These numbers can be anything. These numbers can be anything. So we need a diagonal of 1s. And then the most important part, and the part we need to get first, is the triangle of 0s. So those 3 numbers need to be 0s. Now remember, we can swap rows out. So if it's easy for you to get a 0 here, that's fine, because then you can just move it to that row later on. Now, there's a lot of different methods you can use here. And if you guys kind of enjoy kind of that challenge of just figuring out how to do something kind of on your own, pause the video and just try this using those 3 rules. I'm going to follow kind of the same basic pattern because it always works and it makes it a little bit easier. But again, there may be faster and more creative ways to get there than following the same basic pattern. So the way I do this when I work it out, my goal is to start by getting a 0 in this first column. Right, so getting a 0 sometimes is going to be really easy. So right now, an easy way to get a 0, following those rules, I can add a multiple of a row to another row. This is probably what you'll do the most often to get a 0. So what I'm going to do is I'm going to take the second row, and I'm going to add the first row. Because if I do that, well, -1 plus 1 is going to give me a 0 in the first column, and that's my goal. So when I do that, my new matrix, I have not changed any rows besides the second row. So I'm just going to rewrite those rows right now. And then what I'm doing again, I'm taking the second row and I'm adding the first row to it. So -1 plus 1 is 0. 3 plus -2 is 1. 0 plus 3 is 3. -4 plus 9 is 5. Well, now I have one of those zeros where I want it. All right, so now the next thing I usually do is I try and get another 0 in this column. Well, I'm going to go ahead and try and get a 0 here because I think that's going to be an easy one to get. Because again, if I add a multiple of another row, that would be an easy way to make that a 0. Because if I take this 2 and I add a -2, it becomes 0. Well, I can get -2 by taking this top row and multiplying it by -2. So I'm going to say -2R1. So I'm going to basically take the top row and multiply it by -2 and then add it to the third row. Now, if you want, you can do this in 2 separate steps. If it's a little bit easier, you can take this and multiply it by -2 and then just add those rows together. That might be a little bit easier to see before you guys get used to this. But I'm going to go ahead and do it in one step. So I'm going to say -2R1. So what that does, that means the first 2 rows of this matrix have not changed. But the bottom row, I'm going to take 2 minus 2 times 1. Well, that's 0. That's what I wanted. -5 minus 2 times -2. That's -5 plus 4. Then I've got 5 minus 2 times 3, so 5 minus 6. Then I've got 17 minus 2 times 9, so 17 minus 18 is -9. So now at this point, I have 2 of those zeros that I need. Well, that puts me in really good shape because now I need one of those 2 numbers to be a 0. It doesn't matter which one because, again, let's say instead I got this one to be a 0, I can just flip those rows and I'm done. But what I need is for one of those 2 to be a 0. So what I'm going to do is I'm going to, on this case, it's a little bit easier to see. I'm going to add those 2 rows together because 1 plus -1 is going to be 0. It's up to you which ones you want to add. I'm going to go ahead and take the third row and add the second row just so I don't have to swap. So when I do that, that's going to give me, again, the first 2 rows are not changing. So I've got 0 plus 0, -1 plus 1, -1 plus 3, and -1 plus 5. So now I have my triangle of zeros. That's the hard part. Once you get that, the rest of this is pretty easy. The other thing I need is a diagonal of 1s. Well, I already have 2 of them. And in order to make this a 1 without changing those zeros, this is when I'm going to use the operation of multiplying by a constant. All I have to do is multiply by 1/2. Because that's not going to change any of the zeros. It's not going to change the first 2 rows. And now I have that triangle of 1s. So this matrix is now in what's called row echelon form. What we like about row echelon form is it creates a very easy to solve system. So I'm going to rewrite this as a system. Okay, so this first one, this would be x minus 2y plus 3z equals 9. Y plus 3z equals 5. And z equals 2. And again, this is kind of one of those stair-step systems where substitution is really the easiest method. So I already know that z equals 2. Well, let's plug that in. Y plus 6 is equal to 5, so y is equal to -1. Plug those both into the top equation. So I get x plus 2 plus 6 is equal to 9, so x is equal to 1, and my system's solved. All right, so let's look at another one. So again, I need to start by creating my augmented matrix. So this is going to be -2, -3, 3, 1, 2, -2, 3, 1, 3, 20, 21, and -9. All right, so again, there's a lot of different ways to get your right answer. Okay, you need to do what makes the most sense to you. But again, my method usually, I'm going to start by getting a 0 in this column. And I think the easiest 0 to get to start is by adding those 2 rows together. Again, which one you want to add is up to you. I'm going to go ahead and take the third row and add the second row. So that is not going to change the top 2 rows. But the bottom row now, 3 plus -3 is 0. negative 2 plus 2 is 0. 3 plus 1 is 4. And negative 9 plus 21 is 12. So that was really helpful because that actually gave me 2 zeros. All right, so now let's move on to get another 0. Again, I want to get one of those two numbers to be a 0. So what I'm going to do, you have really kind of, again, a couple options here. If you're okay working with fractions, you can add a multiple of another row that just happens to be a fraction. I know if I have negative 3, if I want that to be a 0, I can add 3. Well, I can get 3 by taking negative 2 and multiplying it by a negative 3 over 2. So what I could do is negative 3 over 2 times R1, and that could be what I can add to that row to create that 0. Now, if you don't like fractions, your other option is you can just make those, again, opposite whole numbers. I could go ahead and multiply this row by negative 3 and multiply this row by 2, and then I'd have a 6 and a negative 6, and I could then add them together to still get that 0. It's just a matter of what you're more comfortable with. I don't mind fractions, so I'm going to go ahead and use fractions. I'm going to do minus 3 over 2 R1. So that is not changing the first row. And it is changing the second row. I don't know why I didn't just have it. There we go. So let's go ahead and actually do the operation for that second row. So negative 3 minus 3 over 2 times negative 2. So that's going to be negative 3 plus 3, which is 0. Then my next spot, I'm going to have 2 minus 3 over 2 times 1. So that's just 2 minus 3 over 2. That's just 1/2. All right, 1 minus 3 times 3 over 2. So that's 1 minus 9 over 2. So that's going to be a negative 7 over 2. And then the last one, I've got 21 minus 3 over 2 times 20. So that's going to be 21 minus 30, which is a negative 9. Bottom row did not change. And that's where we are. All right. Now at this point, you're in a really good shape because, again, we already have this 0. So what I need to do now is go ahead and get that diagonal of 1s. And we can do all of this in one step because it's not one row basically dependent on another row. So I'm going to go ahead and multiply each of those rows by what I need to multiply by to make that one diagonal. So that top row is going to get multiplied by a negative 1/2. That middle row is going to get multiplied by 2. And that bottom row is going to get multiplied by 1/4. So that's going to give me 1, negative 1/2, negative 3 over 2, and negative 10. 0, 1, negative 7, negative 18, and 0, whoops, a little bit too far down there, 0, 0, 1, and 3. And now this is in row echelon form. All right, now at this point, let's set up that easy system. So x minus 1/2 y minus 3 over 2z is equal to negative 10. Y minus 7z is equal to negative 18. And z is equal to 3. Well, z is equal to 3, that's easy. And then again, plug in those values to solve this system. So I've got y minus 21 equals negative 18. So y equals 3. And then I've got x minus 3 over 2 minus 9 over 2 equals negative 10. So x minus 6 equals negative 10, so x equals negative 4. All right, so in addition to Gaussian elimination, we also have something called Gauss-jordan elimination. Now what this does is it really takes that same process a couple steps farther to create a matrix in what's called reduced row echelon form. Now reduced row echelon form, it takes a little bit more work with your matrices, but it's not really hard steps. At this point, honestly, these last couple steps are pretty simple. And it gets your matrix in reduced row echelon form, which gives you not even a system to solve. It just tells you the answer, okay? So what we get is this extra triangle of zeros. So now we know that 1x is equal to this number. 1y is equal to this number, and 1z is equal to this number. So you don't have to go through that extra step of solving. Now again, it seems like it's a lot more work with the matrices, but at this point, once you're already in that row echelon form, it's pretty easy to get to reduced row echelon form. So to show you guys, we're going to go ahead and just take the original examples that we already did. So I'm going to rewrite the row echelon form from our first example. And then we're going to do our row operations. Now, when it comes to your row operations here, and this is also true with your early steps with Gaussian elimination, you need to be careful which row you pick, because what you don't want to do is undo any of the work that you've already done. I'm not sure if that makes sense, but let me show you an example. One step I would not want to do here. I would not want to take the second row and subtract the first row. The reason I don't want to do that, yes, it would give me this 0, because 3 minus 3 is going to give me 0. The reason I don't want to do that, though, is because I would have to subtract the entire row. So not only would I do 3 minus 3 equals 0, I would have to do 0 minus 1 is negative 1. 1 minus negative 2 is 3, 3 minus 3 is 0, and 5 minus 9 is negative 4. Even though I got that 0 where I want it, it's not worth it because I lost that 0 that I already had. And it's possible to get those zeros there using a different row instead. So what I'm going to do instead is I'm going to use the bottom row, because the bottom row has 2 leading zeros. And if I add or subtract any multiple times 0, I'm just adding and subtracting 0. It's not going to then affect the 0 and the 1 that I already have that are already in the place that I want. So again, instead of using the bottom row, instead of taking the second row and adding a multiple to the first row, I'm going to use the bottom row. All right, so what I'm going to do then is I'm going to take that second row and I'm going to subtract 3 times that bottom row. And the reason I want to do that, 3 times 3 is 1, 3 times 1 is 3, 3 minus 3 is 0. So then that gives me, the top row has not changed. So 0 minus 3 times 0 is 0. 1 minus 3 times 0 is 1. 3 minus 3 times 1 is 0. 5 minus 2 times 3, that's 5 minus 6, that's negative 1. And the bottom row has not changed. So again, that makes that whole process a lot easier. So be careful with the rows you pick that you don't undo the work that you've done previously. All right, so now let's get our last 2 zeros. At this point, we don't really have to worry about kind of ruining anything. We're in pretty good shape because, again, we're going to have those leading 1s and 0s. So for this second row, for the first row, I'm going to have to use a number multiplied by the second row in order to get this 0, because 0 times anything is not going to change anything. So let's go ahead and let's do plus 2 or 2. Because 2 times 1 will give me 2, negative 2 plus 2 will give me 0. So the 1 plus 2 times 0 is still 1. Negative 2 plus 2 is 0. 3 plus 2 times 0 is still 3. And then I've got 9 minus 2 is 7. And then my other rows have not changed. All right, then there's just one last 0 that I need. And again, that's pretty easy. I'm going to have to use the bottom row because there's actually a 1 there. The leading zeros will keep me from ruining the first 2 columns. So I'm going to subtract 3 times R3. So 1 minus 0 is 1. 0 minus 0 is 0. 3 minus 3 is 0. 7 minus 2 times 3. 7 minus 6 is 1. Other rows did not change. And now this is in Gauss-jordan elimination. It is in reduced row echelon form. And again, reduced row echelon form is really nice because it makes it very obvious what your answers are. I can see that 1x is equal to 1, 1y is equal to negative 1, and 1z is equal to 2. All right, let's try the same thing with our second matrix. Again, if you feel comfortable, pause the video, try this one on your own. But I'm going to rewrite our answer from the previous one. All right, so again, be careful that you don't undo any of the work you've already done with your zeros. So again, what I don't want to do is I don't want to take this second row and add a multiple of the first row. Okay, that's probably not what I'm going to do anyway because it wouldn't be very easy. So let's go ahead and start by getting this 0 right here. So to get that 0, I would need to add a multiple of the second row. I would need to add 1/2. So there's already a 1 there, so I'm going to add 1/2 R2. So that's going to be 1 plus 0, negative 1/2 plus 1/2, negative 3 over 2 minus 7 over 2. So that's going to be negative 10 over 2, which is negative 5. And then negative 10 plus negative 9. Other rows did not change. All right, now let's look at our next step. Again, I need to get 2 more zeros. All right, one of those ones. And again, what I don't want to do, the first, in order to get this 0, I don't want to use the first row. Because again, it's going to ruin those values that I already have. So I need to do everything in relation to this third row for both of these actually. And if you want, because this row does not correspond to this row, you could do these at the same time. I'm going to split it up, but if you want to do both at the same time, go ahead. All right, so to get my 0 here, again, I'm going to use the bottom row. I don't want to use the second row because first of all, it's an ugly fraction, but second of all, it would change some of those earlier numbers, and we don't want to do that. So I'm going to add 5 times the third row. So that's going to give me 1 plus 0, 0 plus 0, negative 5 plus 5, negative 19 plus 15 is negative 4. Other rows did not change yet. All right, and then going on to my last one, again, I'm going to use that bottom row, so I'm going to add 7 times that bottom row. Top row does not change. Bottom row does not change. 0 plus 0 is 0. 1 plus 0 is 1. Negative 7 plus 7 is 0. And then I've got negative 18 plus 21 is 3. Now I'm in reduced row echelon form. Really easy to see. X equals negative 4, Y equals 3, and Z equals 3. All right, now the one thing we didn't see those examples was an infinite or no solution. So what that will look like if you're using Gauss-jordan or Gaussian elimination, if you end up with the first 3 all zeros, that is an indication that you are not going to have a normal solution. You'll either have infinite solutions or no solutions. If you have 3 zeros and any other number in that last column, then that is no solution. Because again, that's basically saying 0 equals 7, which we know is not true. If you get an entire row of zeros, that's how you know that you have infinite solutions. Because again, 0 equals 0 is an always true statement. All right, so I did tell you guys that this was both the hardest and the easiest method. The reason it's the easiest method is because you can get reduced row echelon form on your calculator pretty easily. So this is going to require you guys to know a little bit of stuff about the matrices in the calculator, which we've talked, again briefly about it. But what we're going to do is follow these steps to get reduced row echelon form. So the first thing that I need is my augmented matrix. So let's go ahead and write that out. So I've got 1, negative 3, 0, and 4. 1, 0, 1, and 12. 1, negative 1, negative 1, and 1. All right, so we're going to use that augmented matrix when we get to the calculator. So let's go ahead and get our calculators. All right, so the first thing that I'm going to show you guys is how to get that reduced row echelon form command. So what you're going to do is you're going to go to Math, which is F4. Then you see that option for MAT. I lied to you, I'm going to enter the matrix first. And then you've got M by N, which is F3. So we're going to enter a 4 by 3 matrix. Whoa, 3 by 4 matrix. Sorry about that, guys. 3 by 4, 3 rows, 4 columns. Let me just delete this. Okay, let's start with reduced row echelon form. Sorry guys, Casios are still a little bit foreign to me. I've been using a TI my entire life. All right, so we're going to start with option actually. So that OPTN button. Once you do option, that's going to give you, it's going to say MAT for F2. And then what we're going to do is we're going to go over to F6 to see some more options. So hopefully remember that's where we found determinant. We're just going to go over one more. And then we've got RREF. So RREF stands for reduced row echelon form. If you want to get row echelon form, you can. But keep in mind, if you're trying to get something in row echelon form, I'm probably going to make you show the work with it. And if you're just trying to get the answer, reduced row echelon form is a lot faster. So once you have that, go ahead and exit until you see your normal screen. Then we're going to go to math. Then we're going to go to MAT. Then we're going to go to M by N. And we're going to do a 3 by 4 matrix. And we're going to enter in that augmented matrix. So I've got 1, -3, 0, 4, 1, 0, 1, 12, 1, -1, -1, 1. And then at this point, once your equation's entered, you press enter, and it tells you your answer. So for this matrix, x equals 7, y equals 1, and z equals 5. So like I said, this is the easiest method because calculator-wise, it's by far the simplest solution. It's the hardest method algebraically, but we are going to have to go through this process and show the work algebraically. Now, to make your row operations a little bit easier, though, it actually is possible to do the row operations on the calculator. Now, you still would need to show what you're doing in your work, like the +3 R2 or whatever it is that you're doing, but you can actually do those row operations on the calculator. So what I'm going to do is I'm going to walk through that first example that we did. Actually, let's walk through this second example. That way, no, we have a multiple in there. Let's go through the first example. And I'm going to show you guys how to do those row operations on the calculator. All right, so in order to do these row operations on the calculator, what you're going to do is you're going to start by going to MAT at F3. So I'm going to go to F3, and this pulls up your list of matrices. Now, I already have my matrix entered. If you don't, you'll press enter, you'll enter the dimensions, and then you'll see zeros in all these places. I went ahead and just typed in that first augmented matrix that we did. And I'm just going to show you guys how to do those row operations. So what we're going to do is we're going to click row op, which is F1. And then that gives you your options. Okay, swap just means switch the rows. Times row is just multiplying by a constant. And then times row plus, that's the one that we do with like +3 times R1, -7 times R2. So you'll probably use that one the most. And that's the one the calculator is probably the most helpful for. So looking at this matrix, again, you have a lot of different steps you could do first. I think the first step that we did was we just added row 1 and row 2 together. So I'm going to go to row plus. All right, and then notice the way that it's written. It says row M plus row N, and it puts the answer in row N. So I want my answer to be in column or in row 2. So I'm going to make row M is my first row. I'm going to add that to the second row, and it's going to put it in the second row. And now I have my 0. Then the next thing we did was we tried to get that bottom left 0. So what we did was we subtracted 2 times R1. So I'm going to do times row plus, which is F3. Okay, K was what we multiplied it by. So in that case, I multiplied it by -2. I did -2 times row 1. I added that to row 3, and I put the answer in row 3 because that's what it's telling me to do. And now there I have my zeros. Then I multiplied by a constant. Okay, I can multiply this bottom row. Well, actually, let me add those 2 bottom rows together to get my 0. So I'll do row plus. All right, row 2 plus row 3. Again, the order here is where it's going to put the 0. If you flip it, it's fine. You'll just have to swap those rows to get it in that form. And then finally, to change that 2 to a 1, I multiplied by a constant. So times row, I multiplied 1/2 times row 3. And now I have that form. So if you're dealing with kind of some ugly fractions here, this can make it easier for you to find those values. Just make sure if you use the calculator in this, you still need to write what your row operation is. So make sure on your work, you're still writing -2 row 1 and all those different steps so we know what you're doing. But again, this is just a good way to be able to check those values. All right, guys, so I know that's a lot today, but again, that calculator trick will hopefully be a big help for you guys and make solving some of these a little bit faster.